Hi everybody. In this video, we're going to talk about, well, an introduction to data science. And so these slides are what I would go over in the very first day of a data science class in a regular fall or spring semester. And so I'm going to give you a little bit of an overview about what data science is, so you may know exactly what you think data science is, or you may have no idea what it is, but have just heard of it and are interested, and so you're taking class. And so people come from wildly different backgrounds to this course. And so I want to give an overview of maybe my view of data science. I'll start off by saying data science is kind of a hard thing to pin down what it is. And so I think that'll be apparent as we go through, but hopefully I can give you something useful here. So, what is data science? And so here's an attempt at a definition. It's an exciting discipline that allows you to turn raw data into understanding, insight, and knowledge, which is supposed to make you excited. Specifically, we're going to do data science in a tidy way with an emphasis on statistical thinking. So if you watched my very first video that went over the syllabus and the slides, I introduced myself as a statistician. That's what my PhD is in, and so it's going to have a statistics flair. So anyway, and then a tidy way. We're going to use a set of packages in R that are called the tidyverse, and they are they call themselves an opinionated set of packages that do data science in a certain way. Basically, the verbs are going to be a certain way. The ethos of what they're trying to do is going to be a certain way. Hopefully not a weird way. I don't think so. I think it's fairly intuitive, and I think it's fairly easy to learn, and so that's why I teach it. There are many different ways to do it. In R, we're going to do it one specific way, and hopefully you'll see that also when we get started. Okay, so many people put this up when they talk about data science. There's a Venn diagram. And so data science falls in the intersection of what I would say statistics, computer science, and then domain-specific knowledge. For a good data problem, you need, well, one, you need someone with the data who knows the questions. So I, myself, since I have a PhD in stats, would like to think I'm okay at analyzing data. But I don't have a specific interest. I'm not interested in turtles. I don't know a lot about turtles or birds or the stock market or finance or whatever. So I don't have a specific interest. I need someone to come to me and tell me I have a problem and I need to do data analysis for it. And so you need that domain and human interface. So you need the domain-specific person to know about the data and to sometimes give you the question. You need computer science because data at a large scale, at really any scale, should never be done by hand. No amount of graphs, summaries, even the most simplest things should never be made by hand. So we need computer science at a simplest level to just, well, make summaries and make graphs and so on and so forth. But we need the algorithmic thinking and hardware and software, hardware, and algorithmic thinking to solve problems in data science. And then we need the modeling of a statistician, the analysis skills of a statistician. So all three of them are intricate into what data science is. Now, that is, of course, my specific view on data science. If you were to look hard enough, you'd find a different one, probably. And so if you, I don't know, didn't like my definition, please do look elsewhere, because there will be a different one. Data science is hard to pin down. So, our book, R for Data Science, defines data science as a, well, not really defines, but here's a process for what data science is. And I think it's a pretty good explanation, a pretty straightforward one. Now, Dr. Bryant, who is a faculty member of the math department, who also has taught some data science courses, he came up with this acronym. So if you think it is cheesy, you can blame it on him and not me, but it's the awesome process of data science. And so in order to do a problem with data, of course, you need to acquire that data, whether it's given to you, whether you go out and collect it yourself, whether you go out and maybe the person did not hand you personally the data, but they put it somewhere and you need to get it off of a website, off of a API, off of somewhere. You're going to need to acquire it. So the first step is acquiring it. The second step, which is really important, kind of lame, but it's going to take up a lot of time, is wrangling the data. So when you get the data, is it in the proper format for you to work with? So does the computer see the numbers as numbers, or do you need to do some work to get them there? Are there spaces? If you're looking at text, are there spaces between the words that are supposed to be there? Are there too many spaces? All kinds of things. Okay, and then you get to explore. So acquire, wrangle, explore. The first three parts are what we're going to focus on in Data Science 1. If you go on to take Data Science 2, which a number of you are, explain, that is Data Science 2. I guess also or see and organize, that's Data Science 1. Model is Data Science 2. So the modeling part of exploring and the explaining part, that's Data Science 2. Everything else is Data Science 1. And so we need to acquire the data, wrangle it, explore it, and we're going to take a lot of time to think about how you explore data well. And then once we do that and get that down, in the next class, we'll model and explain. Okay. So I have a few examples, which are getting kind of old, as in old, maybe like 2 years old, but that's really old for data science and sort of tech world. But is a tweet bot, or is it a tweet bot or not? So if you look at a number of accounts on Twitter, can you tell based on, well, maybe the tweet, or here it's how often does somebody tweet and what time of day do they tweet? Does that tell you if it's a real person or not? So can you detect if it's a tweet bot or not? And so if you look at these 12 different Twitter accounts, I think it's pretty easy to detect whether it's a real person or whether it's not, because of course tweet bots are scheduled. Either they're scheduled or they're sort of programmed to tweet out at a certain time. So anyway, with a little visualization, something that might be hard just looking at a bunch of tweets, sort of eyes will glaze over. If you make an effective visualization here, becomes a very easy problem. Okay. So that's an example. Now, what is this course specifically? Okay, so some information for you. I don't assume that you have any programming background or any background in data science. I guess I do assume a little bit of programming knowledge because you're supposed to have taken CSC 104, the Programming in Python course. Okay, so I don't really expect much out of you. I'm going to try to start from the bottom and build you up and give you lots of resources to help you. Okay, this isn't a programming course. This is not a course in the CS department, but we're going to do a lot of programming. And I will show you as I go along, or I'll comment in my videos what I think is good coding practice, what I would like you to do in naming variables and spaces and so on and so forth. And so watch out for those. This course will pull from a wide array of data and topics to keep it fresh and exciting. At least I'm going to try. You may not agree with me that it's fresh and exciting, but I'm going to try. And this last one is that we will use R, but hopefully the skills, the data science skills that I want you to learn should, at least I hope, translate to other languages. So even though you might not learn Python, which is the other major data science language, so I'm not teaching you to do data science in Python, but I am teaching you skills that should be easily transferable from R to Python. Okay, now I go into a little bit of R. Now I have other videos that I talked a lot about R, and so I won't belabor this too much. You can read the slide if you want. I go through its origins. It was originally started as the language S in 1976 at Bell Labs. Now, Bell Labs used to be or is a precursor of AT&T. And then S turned into R. Two basic things that you want to keep in mind about R is that everything that exists is an object and everything that happens is a function call. That really is going to make a big difference right away for you, but I will reference that throughout to try to help things. So why should you learn R? Well, here's also a little bit of an old infographic. Okay. Hopefully I'll show you that R is not a weird language. You may or may not have preconceived notions about R and what it is. Hopefully you'll find it not too difficult. Okay. Now I have two thought examples that I gave last spring that I think went over fairly well. And so they were the data science thought examples. And because we don't have a live audience, these might be a little tougher. But these are two examples of what I think are doing data science, and they're not really the same. They may actually be quite different. And so one is calculating grades for my winter course, or you could think spring course or whatever. So I use R to calculate all of the grades for my course. And so this is a purely sort of data manipulation task, which is what we're going to do a lot of really early on in the course. And so I have to think through. Now, if I show you I'll go to my winter course here. Sorry. And first I need to show you my syllabus. So my winter course was on Math for Liberal Studies, okay, which is a course that people who don't like math want to take if this is the only sort of math they need to take. And it goes through a hodgepodge of mathematical topics that are actually quite fun, but you probably can't take. You're probably not allowed. So anyway, the important parts here, there's not many course components. There's online homework grades. So they have, say, 20 homeworks, okay, almost daily throughout the course. The homeworks are averaged together and worth 35% of the grade. Okay. Then I have quizzes. So online quizzes. There are roughly 7 or 8 online quizzes. They're worth 20% of the grade. And then there are 3 exams, and I tell them when they're going to be. Okay, 3 exams. I average all 3 exams together, and they're worth 45% of the grade. Okay. And so this, I also have here is what, sorry, it'll take a second. So I took the names away from my students, but I have, so name, student 1, 2, 3, so on and so forth. And so I've got all of my students, so all of the homeworks, quiz, so on and so forth. I have all of their scores here by column, so each row is a student, each column is a grade. Now we will go through and you can think critically about, is that right, or should I have each column be a student? and each row be a homework or quiz or whatever. And that matters in some cases. It doesn't really matter here, but what I want you to do, and feel free to stop the video and just think about it, is how would I say I have 23 homeworks, 6 quizzes, and 3 exam grades. How would I calculate those grades? So I average together the homeworks, I average together the quizzes, and I average together the exams. Okay, and so how would you do that? And so an easy way, probably a way that you are familiar with, is an Excel formula, which is a fine way to do it, and probably the fastest way until you learn something else. Okay, but I want you to think, how could I do that if I had this data set in R or in Python, in a programming language? How could I go through, or not even algorithmically, think through in words, if I were to write down a step-by-step process of how I would calculate those grades? So something like, if I were to start, the first thing I would do is, say for the homework, I would want to, and think of the verbs that you might use. So for every student, I would select all of the homework columns. So I may just pull out or select all of the homeworks, and then once I have that, average them together. Okay. So maybe I'd add them all. I'd make a new column that was the sum, and then I'd divide by the number of columns, things like that. So I don't know if that, hopefully that was a little bit helpful, but think about how I would, in a sort of algorithmic way, do that. Okay, so think about that. And now I have the second example. Oh, sorry. The second example that I have was working with tweets about proteins. So this is a real project that I'm working on with Dr. Russ Hedberg from the Geo and Earth Sciences Department. He has a lot of tweets, 250,000 some tweets about alternative proteins. This is like Impossible Burger stuff. So alternative meats, alternative proteins. And he's interested about how people are talking on Twitter about alternative meats. Who are they interacting with? So on and so forth. This is an example of like what's right up a data science person's alley. So this is a classic sort of data science question. And so how am I going to work with tweets, which are text? Text is easy, is a lot harder than numbers. So how would I try to work with? What kind of ideas might I generate through what is it? What could be interesting? Are people talking to other people who think like themselves? So there are people who will be for alternative proteins, against it, in all different ways. Are those people only talking to each other, or are they talking to other people? How would I define an interaction between two people? Of course, you have to know a little bit about Twitter, but a reply versus a retweet versus a like, so on and so forth. And so think about, there it's a little bit of a bigger picture question. Number one, I think you'll be able to think about, maybe it starts out as being a little too simple about what I would do for number one, but two, a bigger picture. How would I start working with, imagine I gave you a bunch of tweets in a CSV. Every row was a tweet and it has lots of meta information about it. How would I start working with that? And so that's what those are the skills that you're going to hopefully get in this course. How would I start to work with them? We're not going to learn about actual methods to do analysis of words yet. That comes in the second data science class. We will do stuff. You will be able to do number one, no problem, hopefully, by the end of the course. Okay, so anyway, those are two examples to think about. Now, I want you to get started. So I'd give this to the class at the end of the period, at the end of the first class, or near the end. And so it's basically, I want you to do some data science in your very first lecture, in your very first class. And so I give you here directions to do some data science. So once you get into D2L, which you probably already are because you're watching this video, okay, look under the Content tab and find week 1. Inside the code submodule, it's actually called material, I think, at the moment. So inside of material, you should spot a file called unvotes.qmd. You probably also know what a QMD is now if you've watched some of the other videos. Okay, what I want you to do is open it up and then render it or knit it, okay, and then follow the instructions to change some variables, change some part of the document, and see what happens. Okay, so try that, see how it goes. Email me with any questions, and so that's an introduction to data science. Hopefully not too helpful. Hopefully not too scary, and a little bit helpful.